The purpose of this gravimetric analysis lab is to determine the identity of a group 1 metal carbonate. So in this lab, we have two unknowns, unknown 1 and unknown 2. One of these unknowns is potassium carbonate and the other unknown is sodium carbonate. And so the purpose of this lab is to figure out, is the unknown that we work with potassium carbonate or sodium carbonate? And to determine the unknown, we're going to use a process called gravimetric analysis. What we're going to do is we're going to take the unknown, we're going to dissolve it in water, and then put it through a precipitation reaction with calcium chloride. And in the background information of the lab, you will see the three equations that correspond with these series of reactions that we will be doing in order to produce the solid group 1 metal carbonate. So you will see right now I have all of the materials out that we will need for this lab. We will not need the filtration materials yet, so I'm going to set those off to the side. What we're doing first in the procedure is we are heating a crucible. So when you are setting up a heating of crucibles, you want to use an iron ring, a clay triangle, and then you will put the crucible right inside the clay triangle, so it will rest inside the clay triangle. And I'm going to leave this heat-resistant ceramic pad just next to my setup. So when my crucible is ready to cool down, I'll just set it right on the ceramic pad, and I have crucible tongs that I will use as well. And so what I'm gonna do is I'm gonna set up the Bunsen burner underneath this ring stand. So I have the Bunsen burner that I've gotten from underneath the lab table. I'm going to connect it to the gas, and I'm going to just turn, I just want to turn the hose enough so that it sits correctly on the lab table. Now what I want to make sure to do with the Bunsen burner is I want to make sure to close the vents first, so that way we have all of the gas that we will be igniting. I'm going to turn the gas on so it is parallel with the hose. I'm going to take a match. And when I light a Bunsen burner, I want to come up from the bottom. You do not want to go top down because you'll burn your hand. And I'm just going to set this off to the side so I can rinse it with some water. Once you have the flame, you can adjust. Now notice when I adjusted it, it was too much and it went out. So I'm going to close it again. Light the match, come up from the side. And what I might have to do is adjust the gas just a little bit. And if you notice that it starts to go out, then just leave it like it is. And so now I have the Bunsen burner set up. I have it lit. And then we're gonna brush the bottom of the crucible with the flame for 1 minute. So when you brush it, you wanna just wave the flame back and forth. You do not wanna let it sit because then it's going to heat the same spot on the bottom of the crucible and it will crack the crucible. So for 1 minute, we will go ahead and brush the flame. And what we're doing is we are making sure that we heat any water that might be inside the crucible. We want to make sure that that is gone. We don't want any water to affect our results. So after 1 minute, to turn off the Bunsen burner, we're just going to turn off the gas, set the Bunsen burner down, and now it says that we want to allow the crucible to cool to the touch. Do not touch the crucible right away. Let it sit there. We're gonna let it cool down for quite a while. And while we let it cool down, we'll look ahead and we'll see what we can do to set up the next part of the lab. So now that the crucible is cool to the touch, I am going to measure the mass of the crucible using our electronic balance. So again, there's a plastic cover on the balance. You want to make sure that that's always lifted up. Make sure that the balance is at 0. If not, you want to hit the 0 button. And then we're going to take the crucible and we're going to put it directly onto the scale. So the mass of the empty crucible is 20.78 grams. So make sure that you record that. Now we're going to take one of the unknowns and we're going to add 2 grams to the crucible. Whichever unknown you pick is up to you. We will go ahead and use unknown 1 I will give you the data for unknown 2 as well. So if you want to do the other unknown, that's fine. So for unknown 1, make sure that you write down, you record that we're using unknown 1. So I want to add 2 grams. So I want to get as close to 22.78 grams as I can. And you want to be very careful. So you want to be as close to 2 grams as you can because you want this metal carbonate to be the limiting reactant. If it's a little less than 2 grams, that's okay. So I'm going to stop here, 22.64 grams. So make sure that you write down that we used unknown 1, and unknown 1 has a mass of 22.64 grams with the unknown and the crucible. So now that we have the crucible with the unknown, we're going to take it back and we're going to start heating the crucible. So now that we have the metal carbonate in the crucible, you want to make sure you make an observation of what it looks like in the crucible. We're going to put it in the clay triangle and we're going to heat it. Now, when you heat a substance in a crucible, you want to put it in the clay triangle and you want to tilt it just a little bit, just like the figure in the lab. And that is to allow the water to escape. So the whole point of heating this crucible with the substance in it is that we want to remove any water from the substance. We want to create an anhydrous substance. And so what I'm going to do is I'm going to light the Bunsen burner as before. So I'm going to turn the gas on, take the match, heat the Bunsen burner. And now once the Bunsen burner is heated, it says that you're going to brush the bottom of the crucible for 2 to 3 minutes. So as I brush the bottom of the crucible, I want to go back and forth. I don't want to hold it in the same spot. What's happening is any water that is in the substance will escape into the surrounding air. And these substances are hygroscopic, which means they absorb water from the air. And so because they're hygroscopic, we want to heat the substance in the crucible to remove any water. So I'm going to go ahead and fan this for 2 to 3 minutes, and then we'll find the mass again. So what I'm going to do is I just stopped fanning. What I noticed is that some of the substance, some of the unknown started popping, almost like popcorn. And so I'm going to stop, I'm going to let it cool. And to let it cool, we're going to use crucible tongs and we're going to remove it from the clay triangle because the clay triangle and the iron ring will be very hot. So I'm using crucible tongs. I'm going to very carefully with both hands pick up the crucible. I'm going to set it onto a ceramic pad and I'm going to let it cool completely. And the reason that we let this cool completely is because if we try to find the mass of something that is warm, the mass will be slightly less than what we would expect because it's creating convection currents. And so it's warming the air around it. And this is going to cause the mass to be a little bit lower. And so we want to make sure that it's cooled completely to ensure that the mass is accurate. So now that the crucible is cool to the touch, I can pick it up, I can hold it. I'm going to find the mass after the first heating. So after the first heating, the mass is 22.62 grams. So notice how it has changed slightly. Oh, no, it went down. So let's change that to 22.62 grams. Sometimes it goes back and forth a little bit. So we're just going to take it wherever it stays the most because there is a vent up above the lab. Sometimes it does affect the weighings a little bit. And so we're going to say 22.62 grams since that's where it's at for the most time. Notice, again, you can make observations of the unknown. And we're going to go back and we're going to heat it again. So now we are ready for our second heating. And so I'm going to make sure to turn this. Again, you want to try to make sure that it's at a slight angle. I know the picture in the lab shows it laying down, but sometimes with that you want to be careful so that it doesn't roll off. So as long as it is slightly angled, we will be okay. Now what we're going to do again is we're going to light the Bunsen burner. So I'm going to turn the gas on, light the match, and I'm going to come up from the bottom. Okay, and then again, we're going to heat. So we're going to heat this again. We're going to repeat the steps until the mass stays constant. And the reason we want the mass to stay constant is because, like I had said before, metal carbonates from group 1 are hygroscopic or hygroscopic. Those words are synonymous. That means that they absorb water from the air. So by heating this until the mass stays constant, we ensure that the crucible and the substance inside the crucible is anhydrous. So there is no water in the substance or the crucible when we go ahead and complete the reactions. So again, now that our crucible is cool to the touch, I'm going to go ahead and find the mass. And so the mass after the second heating is 22.61 grams. So again, in your data table, 22.61 grams is what you want to make sure to record. Now, since the mass did slightly decrease when we just found the mass, I am going to heat it for a third time. So even though it changed only by 0.01 grams, I do want to make sure that any water that is in the crucible or in the substance is removed. So I'm going to do one more heating, and hopefully the mass doesn't change from this final heating. To adjust the oxygen so that I get this nice cone, and I'm going to go ahead and I'm going to heat for the third time. Again, I'm going to be fanning the flame, brushing it back and forth for just a couple minutes, just to ensure that any water is gone. And once I'm done heating, I am going to let it cool to the touch again, and then I'll find the mass once more, and hopefully it doesn't change anymore. But the reason that we want to make sure to continue to heat is so that any water is gone. And there are other labs like determination of a hydrate, where you can actually figure out that coefficient in front of the H2O by doing something similar to this. And we can record as an observation that some of the substance was kind of popping out of the crucible, so that could be a potential source of error. So whenever you notice that something like this is happening, you want to record that in your lab notebook, just so that when you are trying to determine sources of error, you can look back and see if there was anything that you wrote down that could attribute to error in the lab. So once again, the crucible is cool to the touch. We have the unknown group 1 metal carbonate. I'm going to go ahead and put it on the scale. And it reads 22.61 grams. So after our third heating, 22.61 grams. So since the mass stayed the same, we are now ready to move on to the next step in the procedure. So now that our unknown metal carbonate has removed all of the water, So from the heating, all the water has been removed. We can now move on to the next step in the procedure, which is dissolving the metal carbonate into water. So I'm going to add the crucible contents into a clean, dry 400 milliliter beaker. So again, 400 milliliter beakers, notice how on the side it says 400 milliliters. I know it does not go all the way up, so the markings do not go up to 400, but if this were filled completely, it would hold 400 milliliters of liquid. So that's something that a lot of people will get tripped up on when they're looking at the beakers. Beakers are typically what you will conduct reactions. So it's the reaction vessel, this or an Erlenmeyer flask. So we have the 400 milliliter beaker, and it says add about 200 milliliters of distilled water to the beaker. So since we're not looking at exact amounts of distilled water, it just says about 200 milliliters, we can just use the markings on the beaker. Normally we use a graduated cylinder to measure precise amounts, but since we just want to dissolve the substance into water, I'm just going to pour up to about the 200 milliliter mark on the beaker. So again, we have our distilled water bottles that we keep in the lab. And now what we want to do is we want to take our clean stirring rod. We want to go ahead and stir. So the whole point of dissolving the unknown metal carbonate into water is to dissociate the ions. So what we're doing is we're taking the unknown cation, either Na plus or K plus, and the CO3 2- ions, and we're dissociating it into its ions. And that's because anything with potassium, nitrate, ammonium, or sodium within the ionic substance is soluble, meaning it will break up into its ions. So you want to make sure that you record your observation. So record what this solution looks like. So hopefully you don't see anything. It should just be a clear solution. And now what we're going to do is we're going to add 125 milliliters of this 0.2 molar calcium chloride solution. So this is exactly 0.2 molar. Make sure you record the exact concentration in your lab notebook. So it's 0.2 molar. So 125 milliliters. I have this 100 milliliter graduated cylinder. So what I'm going to do is I'm going to go ahead and pour to the 100 line. You want to make sure you read it at eye level. So there's 100 milliliters. And let's add another 25. And you want to make sure if you go over at all that you record that, but I got it to exactly 25. So we've added 125 milliliters of the 0.2 molar calcium chloride. And we want to go ahead and stir this solution. So make sure you're recording your observations. You should notice that something happened here. So now we're going through this precipitation reaction between CaCl2 and this M2CO3M, meaning either K or Na. So I'm just stirring, making sure that reaction is proceeding to completion. And now what I'm going to do is I am going to go ahead and just let this precipitate settle for about 5 minutes. And so hopefully what we see is that the precipitate, the solid, will settle to the bottom, and that will leave just an aqueous solution up on the top. So while we are allowing the precipitate to settle, what we're going to do is we are going to prepare our filter paper and the filtration setup to filter the solid from the aqueous solution. So we have a piece of filter paper. Whenever you are filtering, you want to make sure that you get in the habit of first putting your initials somewhere in light pencil along the edge of the filter paper. You want to use pencil because if you use pen, it will bleed through the filter paper and could potentially affect your results. You always want to make sure that you are recording the mass of the filter paper before you do anything to it. So once you have your initials on it, you want to go ahead and you want to take the mass of the filter paper. So the mass of this piece of filter paper is 0.72 grams. So make sure that you record that in your lab notebook. Once we have found the mass of the filter paper, before doing anything, you always want to make sure that you find the mass of a piece of filter paper before you filter, and then you'll find the mass again after. Once we have the filter paper with our initials on it, we're going to fold it. And so we fold it in half. And then we're going to go ahead and fold it in half again. Now what I'm going to do is I'm not going to fold it exactly in half. I'm going to leave this little lip. And then when you open filter paper, you're going to notice that you have 4 pieces. You're going to take it 3 pieces on one side, 1 on the other. And then you have your cone for filtering. All right, so here you have your filter paper. Now, I don't really have anything set up right now for filtering. So I have my filter paper in my hand. I'm going to take a funnel. So we have glass funnels. I'm going to go ahead and put it in the setup that we already had when we were using the crucible. Now this is cool. So I have a clay triangle that I'm going to put the funnel into, because if I didn't have this clay triangle, it would fall right through the iron ring. So now that I have my filter set up, I have my funnel, my filter paper will go right into the funnel. Now notice I don't have anything underneath it. I'm still letting my precipitate settle, but notice I don't have anything underneath this funnel. So what I'm going to do is I'm going to get an empty beaker to go underneath the setup. Now if it's up too high, it might splash out. So if you need to, you can lower it so that the stem of the funnel is in the beaker. Now notice how my paper is not staying in the funnel either. What you can do is you can take some distilled water and you can just squirt some distilled water around the filter paper. And what this allows you to do is this allows you to kind of create this seal in the funnel. And notice how now it's dripping out. So once our precipitate has settled, what we're going to do is we're going to go ahead and we are going to filter. So to filter, we always want to use a stirring rod. Now you want to be careful that you're not pressing too hard into the paper, because you don't want to poke a hole. If you poke a hole, you're going to have to do it all over again. And so what we're going to do is we're going to take the edge of the beaker, right, so the lip of the beaker, and we're going to pour down the stirring rod. That prevents splashing. So I'm going to pour some down, but I want to make sure that I'm not getting the liquid level up above the piece of filter paper. And what I'm going to do is I'm going to continue to filter this. I'm going to continue to go through. At the very end, when my beaker looks empty, I'm going to rinse it with some distilled water, and then I should eventually have a solid in the filter paper. Now I want you to make some observations. First, make an observation of what the filtrate. So what is in the beaker down here is the filtrate. So that's the aqueous solution that gets filtered through. Make an observation of the filtrate and make an observation of the solid. So what color you see the solid so far. Something else I want you to make an observation of is what you notice in the stem of the funnel. Now what these are is these are air bubbles, which means that I did not have this piece of filter paper completely sealed against the funnel. And what happens is that causes these air bubbles in the stem of the funnel. That's something we want to keep an eye on, because if we notice that the filtrate starts to get cloudy, that means that some of the solid went through the funnel and I'll have to filter it again. As you get down to the bottom of the beaker, you'll notice that there's more and more solid that's starting to settle out of the solution. And so as you're filtering and you're getting closer and closer to the bottom, it's good practice just to mix the solution so that you're suspending the precipitate into the solution so that it's kind of floating around. That way, as you're filtering, you can be sure that you're actually pouring some of the solid out with the filtrate as well. So as you get down closer and closer to the bottom, just keep stirring right before you filter. And then again, you can notice the filtrate down here. You can look at the difference between the precipitated solution and just the filtrate. And then we have our solid that is up here in the filter paper. So once we're completely done filtering, we will remove this filter paper, put it onto a watch glass, and we'll put it into the drying oven. Once we get down to essentially the bottom of the beaker that had the precipitated solution, we want to use some distilled water to rinse out the beaker and to rinse out the stirring rod. And so what we're going to do, if you notice the stirring rod has some white solid on it, that's going to be the last thing that we're going to rinse into the filter, because we're going to continue to use this. So we want to make sure we pour out the rest of the solution down the stirring rod. And what you'll notice is that there's a lot of white solid in this beaker. And so what we're going to do is we're going to use the distilled water, and we're just going to squirt the inside of the beaker. Now, you don't want too much water, because all of the water that you're squirting into the beaker still has to go through the funnel. So what you want to do is you want to try to get the sides. You can use the stirring rod, try to scrape the bottom. So you want to try to scrape the bottom as much as you can, and you want to continue rinsing into the filter paper. The water that you're adding is not going to affect the solid at all, because it's going to get filtered down through into the filtrate. But you want to make sure you get as much out of the beaker as possible. Now, there's always going to be some solid left over into the beaker, which should be part of your observations, because that means that not all of the solid is transferred into the filter paper. And so that is one potential source of error. We cannot get 100% transfer. After you have poured all of the precipitated solution through the filter, you want to, like I said, make some final observations of the container that the precipitated solution was in. So if you notice, there still is some solid on the bottom that we were not able to get out. Most of it came off the stirring rod, but there are some small solid particles on there as well. So you want to make sure that you add that to your observations. And then what we're going to do is we're going to remove the filter paper from the funnel, and we're going to put it onto a watch glass and then transfer it into the drying oven for about 15 to 20 minutes. So what you can do is you can use either the end of a spatula, or you can use forceps to remove the filter paper. I recommend a spatula, because if you try to pull on a wet filter paper with forceps, it could rip the filter paper. And so what I'm going to do is I'm going to take the flat side, and I'm going to slowly just go around the filter paper just to gently release the seal. And then, since I have gloves on, I'm going to just use my thumb to slowly pull out the filter paper, being very careful to not touch the very bottom where the solid might be. And what I'm going to do is I'm going to then move it over the watch glass. There is still some water, so I'm just going to lay it out. And you can actually see that we have a white solid on the filter paper. And what I'm going to do is I'm going to now transfer it into the drying oven for about 20 minutes to let it completely dry out as much as possible before I take the mess. I have removed the filter paper with the solid, so you can take a look at the solid. You can make your observations. And what I'm going to do is I'm going to find the mass of the filter paper and the solid. So since the scale is not reading 0, I'm going to press 0. And I'm going to go ahead and I'm going to put it on the scale. So it is evened out at 2.14 grams. So in your data table, you want to write down mass of filter paper, and this is the calcium carbonate. So this is the filter paper and calcium carbonate. And let's go ahead and write down 2.15 grams. So after being in the drying oven for another 5 minutes, here is the solid calcium carbonate. I'm gonna go ahead and find the mass again. So the point of putting it back in the drying oven was to try to remove any more moisture, any excess of the solution, the filtrate that may have still been part of the precipitate. And so after going in for another 5 minutes, notice that the mass has slightly decreased to 2.12 grams. So now in your data table, you have mass of filter paper and calcium carbonate of the second weighing. We'll go ahead and label it. Now we have 2.11 grams. So instead of 2.12, let's label it 2.11 grams. And now we are done with this solid, so we can go ahead and throw it away. This is actually just chalk. Calcium carbonate is just chalk. So from the series of reactions that we just completed, we created chalk. And so what you're going to do is you're going to use all of the data that you've collected in this lab. You're going to go through the post-lab questions to try to identify the molar mass of the unknown metal carbonate that we started with by stoiching from your number of moles of this calcium carbonate. You use the balanced equation and go back to the unknown, and then you'll determine the molar mass. Based on the molar mass, you can identify whether it was sodium carbonate or potassium carbonate, and then we can figure out our percent error.